from your break. So if now we were to look into equation number 2, right? So our objective is to determine R. So we know that 3R squared, right, is equal to stress U squared minus by stress average squared. And if we were to determine R, okay, so R will be equal to what? R will be equal to square root of stress U squared minus by stress average squared divided by 3. Okay. So some of you might say, Eugene, why are we looking for R? How can finding the radius, okay, how can finding the radius help us to solve our torque? So I'll copy this image. Okay. Okay. So how will R help us solve our torque? That's the question. Right. Okay. So we know at the end of the day, what we want to determine is this. And with this expression over here, with shear xy equal to shear yx, we know that this is equal to TR over J. We know if we were to know shear xy, we know the radius, we know the second polar moment of area, then we can determine our what? Our torque. So how will R help? Okay, how will R help? So by knowing our R value, right? So by knowing our R value, we know that R is also equal to what? Square root of your stress average squared plus by shear xy squared. Okay, right? So from here we know that we from here we can determine what? Our this symbol over here, shear xy, is equal to what? R squared minus by stress average squared and the whole thing square root. Okay, right? So now we have to determine our R. Okay, we have to determine our R. So our R is from this expression over here. So I'll call this equation number 3. This is our equation number 4. And this is it. So this is the solution path as you can see now. Okay, or not something else. Why are we doing this for? Okay. So we know first we have to calculate stress average. Is equal to stress x plus by stress y divided by 2. We know that normal stress in the x direction, right? We know, I know it has been a while, okay? We know that normal stretch in the x direction is equal to 0, right? Normal stress in the x direction is equal to 0. And the y is 33.953. Okay, so from here, we know it's 0 plus by 9 minus 33.953 times 10 to the power 3 divided by 2. So this is equal to 33.953 minus 16.977 times 10 to the power 3 psi. So from here we can find our radius, right? So I'll use our next page. I'll get rid of this diagram. Oh no, I think I need a new page because I need all the diagrams over there. E06. Okay. And I think I need. Yep. Right. So from here, right, we know our stress average, right? Then we can find our R. Okay, so R. So using equation 3, right? Using equation number 3, R is equal to square root of stress U squared minus by stress average divided by 2. Okay. So if we were to compute this, so the yield is at what? The yield is at 42. Okay, so minus 42 times 10 to the power 3 squared minus by our stress average. This is divided by 3, Eugene, come on. And then our stress average we found is 16.977. And then the whole thing we divide by 3. Okay, so this will be equal to 42. So divided by 3 and then square root. So it's equal to 22.179 times 10 to the power 3 psi. Okay, so now we know the radius, and this is also equal to our tau max, right? So next we are going to use equation 4a. Okay, so equation 4a. Which is equal to shear xy squared, or shear xy is equal to square root of, I think it's r squared minus by stress average squared. Okay. So we know our radius, which is also equal to our tau max. This is equal to 22.179 times 10 to the power 3 squared minus by our stress average, which is equal to minus 16.977 times 10 to the power 3 squared. Okay. And this will be equal to 22.179 power 3 squared minus by 16.977 power 3 squared. Square root of the whole thing is equal to 14.271 or 14.272. So from here, we know that shear xy is equal to the torque in the y direction multiplied by the radius divided by j. Okay. So we know that this expression torque in the y-axis rj is equal to pi over 2 multiplied by r power 4. Okay. So you can cancel, this is cube. So at the end of the day, we just need to do 14.272 times 10 to the power 3 talk about y is what we're going to find out. Then we have to divide by pi over 2. Radius is 0.75, and this thing is cubed. Okay, so therefore, talk about y is equal to 14.272 power 3 times by shift pi divided by 2 times by 0.75 power 3 is equal to 9.458 times 10 to the power 3 psi. Okay. Now, this is the torque, okay? However, we have to check another thing. Okay, we have to check. Okay, we have to check. Okay, after we know the torque, okay, I'd like to remind you all this. Okay, we have to check that stress A and stress B must be less than what? 42 times 10 to the power 3 psi. Okay, so we know, right, from Mohs circle, we know that our radius, okay, by working out our from our radius, right? Remember, this is not the same as Tresca. Okay, so after we determine our radius, we have to ensure that stress A and stress B are less than what? Plus minus 42 times 10 to the power 3 psi. Okay, we have to ensure that. So from here, to determine stress A and stress B are not difficult because we know the formula, right? So stress A and stress B is equal to the stress average plus minus by the radius, which we have this value. So the stress average is equal to minus 16.997 or 16.977 times 10 to the power 3 plus or minus by the radius is equal to what? Radius is equal to 22.179. So 22.179 times 10 to the power 3. So this will come out to minus 16.977 plus by 22.179. It's going to minus 39.156 times 10 to the power 3. And stress, the other stress is minus 16.977 plus 22.179. It's got 5.202. So if to ask to calculate the factor of safety, it's equal to stress U divided by stress A or stress B. Okay, so for this case, you pick 39. So factor of safety is equal to minus 42 times 10 to the power 3. Why minus? Because it's a compression that will dominate. Okay. And then you divide by minus 39.156 times by 10 to the power 3. So the factor of safety is equal to 1.073. So the structure will not yield at all. So this is the procedure, okay, of solving problems with either Tresca or Vomesis. Okay. Now, what I'm going to do further, right, for today is now, right, we are going to now use, or now we're going to use Tresca criteria. Okay, we are going to use Tresca criteria to see what happened now. So we know from Vomesis, I'll write this down first. Okay, so from Vomesis criteria, right, the torque is equal to what? 9.458 times 10 to the power 3 pound inch. Okay, I do apologize. This is not PSI. This is pound inch. Okay. So now we are going to use Tresca. Okay, we're going to use Tresca. So Tresca, when it's Tresca, what do we do? Okay, we know material property. That